In this video, we're going to go through synthesis reactions. All right, here we go. Here's a classic synthesis reaction. We have some ballpark hot dogs and some hot dog buns. When we put them together, what do we get? Well, we get hot dogs. Yeah, we just put them together. Here's another one. We have a bagel and we have some cream cheese. What do we get when we put them together? We get a bagel with cream cheese. Here's my favorite. We have some gourmet nacho cheese, and we have some tortilla chips. El Milagro, my favorite. We put them together, what do we get? We get nachos. Yeah. So that's pretty much all a synthesis reaction is. We have one reactant, another reactant, and when we put them together, we get a compound. That is reactant A and reactant B smashed together. So our steps. Step number 1, figure out the charge of both reactants. Then we're going to figure out the ratio of A and B needed to make a neutral compound. We always put the cation first and the anion second. And then finally, we balance. So here's an example. We have potassium and fluorine. Okay, so step number 1. Let's figure out our charges. Well, potassium is in group 1, so it's going to have a charge of +1. Fluorine is in group 7, and it has a charge of -1. Now, even though there's 2 of them here, okay, still -1. So when we put them together, it'll just be K and F, positive and negative, and they cancel each other out. Let's balance. So I write out my list of everything. On my left side, I have 1 potassium, 2 fluorines, 1 and 1. So if I put a 2 here, that makes that a 2. It makes that a 2, because remember that 2 distributes to both terms. Okay, and then I need 2 potassiums on the left side, so if I throw a 2 there, that becomes a 2. Balanced. Let's do this example. So we've got hydrogen, +1, oxygen, -2. So when we put this together, I wonder if you know what this one is. I need 2 hydrogens for every water. 2 hydrogens for every oxygen. It makes water. Okay, so let's make our list of what we've got. 2 of those, 2 of those, 2 of those, 1 of those. Let's put a 2 here. Remember that 2 distributes. That becomes 4. That becomes 2. And then let's put a 2 here. That becomes 4. Done. Balanced. Let's do another one here. Okay, so magnesium is +2. Nitrogen. Ooh, this one's a little harder. This one's -3. Okay, so we're going to need a least common multiple here. So the multiples of 2 are 2, 4, 6, 8. Multiples of 3 are 3, 6, 9, 12. The least common multiple is 6. So I need 3 magnesiums. 3 times +2 is +6. And then I'm going to need 2 nitrogens. 2 times -3 is -6. All right, let's count them up. Hey, 1 magnesium, 2 nitrogens, 3 magnesiums, 2 nitrogens. So I just need to put a 3 right there. And balanced. Next one, got aluminum and oxygen. Aluminum is +3, oxygen -2. This is almost like the same problem we just did. Least common multiple is 6. So 2 times +3 is +6. Oxygen, I need 3 of those. 3 times -2 is -6. And let's balance. 1, 2, 2, 3. Okay, so I'm going to need a common multiple between 2 and 3, which is going to be 6. So let's put a 2 here. 2 times 2 is 4. 2 times 3 is 6. To get my 6 over here, I need a 3. 3 times 2 is 6. And then to get 4 aluminums, just put a 4 there. 4 times 1 is 4. Balanced. Okay, this one's a little harder. Okay, so it says iron, Fe plus 3, reacts with Cl2. And what is that going to form? So it tells me this is iron plus 3. Chlorine is minus 1. So I'm going to need 3 chlorines to balance my charges. And let's add up what we've got. 1, 2, 1, 3. So same thing. For the chlorines, we need a least common multiple of 6. So if I put a 2 here, 2 times 1 is 2. 2 times 3 is 6. On my left side, I need a 3 right here. 3 times 2 is 6. And I need a 2 right here. 2 times 1 is 2. Balanced. And that is a synthesis reaction.